and different types of networks, LAN, MAN kind of stuff. Maybe same sequence are different sequence. Okay. What is intranet? What is internet? What is small office, home office kind of network? What is default gateways? What is NIC? Media networking devices, the protocols, and logical addresses means IP addresses, OSA model, okay, TCP IP model, troubleshooting using a OSA model, some networking commands, some networking commands. With those things we are going to learn here. Okay, already I told. So the networking, the PPTs are usually for guideline purpose only, guys. Just I will sometimes see this ring topology, bus topology kind of stuff. I don't keep it in a I don't give lines sometimes. Okay, sometimes I will keep it more information in notes. So first follow the notes and also refer the PPT. Okay, sometimes you miss there, you will cover up here. Okay, sometimes the certain points will be added in the daily notes. So in IP addresses, guys, this is will take 3 to 4 days of class. So now is today is Wednesday, Thursday, Friday, and Saturday. By the time target is, you should complete this networking. Networking topic is a very big topic. Okay, and
Sir,
of
on
course
Saturday we will be having class.
we have a class on Saturday. I will inform if in case if it is not there. Okay.
No, yesterday you told that the classes will be from Monday to Friday only. So
I didn't
yesterday.
told. I never told Monday to Friday. Even I told. I will check it once. I didn't give any days. Soft skills calls. Soft skills calls will be on. I think you attend Prakash sir class. Okay. Soft skills calls
Maybe.
Monday to Friday, but we are working on Saturday. Yeah, for me also it is leave. Okay. For me also it is off. But the syllabus is technical syllabus. It's not that much easy like to cover. So better have one day. So if any gaps, some issues, it will be resolved. Okay.
Okay, sir, no issues.
Uh, Sir, technical interview will be computer based or what?
No, no. Also like face to face means through meeting, like Google Meet or their meeting is there, web meeting only. Okay,
Okay.
not computer based. Guys, at least read once daily what we are discussing daily. Okay, not only same day class, previous day classes, like that. If you keep referring, guys, I am having a almost more than 10 years experience, 13 years experience. I have more, not 13, 14 years experience in this field. Okay, at least 13 years, take it as plus or minus about 13 years, forget about months, at least 12, 13 years of experience in this training field. Okay, I know how people can able to easily remember. It's a very simple technique, guys. No need to do very hard work. No need to use words like concentration kind of stuff. Okay, knowledge, intelligence, smartness. Nothing is required. The very simplest thing is simply daily check what we are discussed. See once, read once. You understand. Read it again. Try to present it. Present it means start speaking about it. So you will understand the subject automatically. I have learned so many subjects, so many technologies, so many practicals I have done, and nothing. Mostly the training classes what I have attended, that is telling only 5%, 10%, maximum 20%. But how I understand what they told, even there are very good people. But thing is, you have to study again, once again, at least once. Then next you will try twice, thrice, and most of the people don't do it. Okay, even we tell, so read it once again. Ah, it is not my matter, guys. It is not even a job, guys. You have a knowledge. then you are useful. You don't have a knowledge, you're useless. That's a simple thing. Lot of people are telling it's the only thing is manage, manage, manage. Manage is nothing. Manage, keep how many days you will do manage without having knowledge and stuff. Okay. So management is important. That's only 20%. So people say knowledge is 20%, 80% is management. That is wrong concept. Really, it won't work like that. Big companies, only because of management, they destroyed. Okay. So that's the point. Okay. Compulsory read,
Sir,
guys. Interviewer.
in technical interview, questions will be asked from these the classes which we are going on, or
We
apart from
cannot
this.
expect what the questions they will ask, but most of the questions are relevant to our topics only. Pretty straightforward certain questions, at least 50-60% of questions straightly from technical questions from our classes. We are not giving question paper to HCL, right? They're asking
Uh,
questions.
yeah,
Some
yeah. Okay,
questions,
thank you, sir.
okay, some questions compulsory. You need a general basic knowledge, basic from yourself. That's the thing. Okay, most of the time, this these are very helpful for not only not 100% we can't give, but 50-60% straight questions. Even we are teaching while keeping the mind about the questions papers on. What are the interviewer asking questions? We keep it that questions in mind, and then we are teaching. Okay, we are not telling the this is the question, this is the answer, but we keep it that in mind and we are teaching. That's why first day class, what I told, this is the one question. What is your system configuration? That is one question. Directly I told one question. Okay, without telling this is the question, this is an answer, I given full information. Okay, so that is the way you have to learn and you have to practice. Not like questions and answers. If you want questions and answers, I will give you, no problem. I will tell where to search that. Yeah, anyway, we have to start, guys. So this is also one question. What is network? That is network. What is network? Interconnection of two or more devices is called a network. Interconnection of two or more devices is called a network. Communication between two or more devices. Communication between two or more interconnected devices called a networking. What is internetwork? Connection of two or more networks. What is internetworking? Means communication between different networks. Okay, here I will try to do a small diagram, guys. Small picture it is. Okay, I have a computer. So first definition is what is the first part? Connection of two or more devices. Connection of two or more devices called a network. Here I use a device called a hub or a switch. Okay, so this is either hub or a switch. This is a thing like here there is a computers. Not only computers, guys, they use a word called device. It means it can be a computer or it can be a printer, it can be a mobile phone, I like that. So connection of two or more devices called a network. For example, this is a device A1 device, B1 device, C1 device. So this is one network. is a network, something like it's a one network. This is a one network. If A1 can able to communicate it to B1, A1 is able to communicate B1 means there is a communication, right? So it's a networking. Communication between the devices called a networking. Communication between interconnected devices called a internetwork devices called a networking. So you have a communication means networking. With just a connected networking. Okay. So for example, I have another network, different network, maybe different place or same place, different network. Okay, it's not, it is a different network. Okay, this is another network. So this is another network, network 2, network 2. Okay, this is another network. So A2 can able to communicate. A2 can able to communicate B2. Okay, A2 can able to communicate B2. And C2 can able to communicate A1. Okay, so networking is there. But this is a different network. This is a different network. Now, I want to make a communication between A1 to A2 or A1 to B2 or B1 to C2 or B1 to B2. Okay, I want to make a communication with these networks. What I have to do? I need a device to make a connect different networks and networking. Okay, I need a particular device to use it to connect these devices. Okay. Now I can able to communicate from A1 to B1 through this line. So it is a interconnection of two or more devices. It's not interconnection, guys. It is a connecting two or more different networks. It is a connection of two or more different networks. Okay, and a communication between different networks. connecting two or more different networks and communication between different networks. So this is internetworking. In internetworking, I can able to communicate from this A1 to this A2, for example, like this. Okay, so this is internetworking. So all definitions are came. What is network? Connectivity. What is networking? What is networking? Communication between interconnected devices. What is internetwork? Connection of two or more networks. What is internetworking? Is a communication between different networks. Yes, to create a network, okay, we generally use a switch or a hub. Hub is a device, okay, and a switch is also a device to connect in a network. In generally, in a device manner. Internetworking. Okay, exactly reverse manner I will tell. Hub or a switch use it to create a network. Use it to create a network. Router is a networking device, not only network. Internetworking device. It means it make communication between different networks. Okay, so this is called one segment, this is called another segment. Separate networks. We are able to communicate between the separate networks to the router. Internetworking. Okay, guys understand?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Next, because of we are discussing about network. The first point is network. Is it a physical network or it is a physical network or a logical network? Network can be a physical network or a logical network. Of course, first of all, physical network must be there, then logical network. If you say network means it's a physical network, means physically connecting devices. Okay, what is physical networking? Means connection of devices. Connection of devices. How you logical network or a logical topology. Is based on a configuration of IP address, means logical address. IP address is a logical address. It's a it is physical network means connecting, how they are connected. Okay, connected devices. Logical network means IP configuration. IP configuration to the devices. So configuration of IP address based on configuration of IP address to the devices. Okay. That is logical network. Logical topologies is based on IP address that defines is it the same network, different network. Physical network based on the connectivity. Okay. So here I am writing physical topologies. What is physical topology? The way of devices connected. Different physical topologies in physical network. So you are connecting devices. So how you connected devices? How you connected device? The way of connect devices connected is physical topologies. What are the physical topologies are there? Bus topology, ring topology, mesh topology, star topology. These are the main topologies, guys. Hybrid topology. These are the main topologies as per the textbook. Some people are adding up newly these topologies point to point, additional topologies. Point to multi-point. And next, three type of topologies. Okay, some other any additional topologies also. Okay, these four names plus one is important. Bus topology, ring topology, mesh topology, and star topology. Okay, so this is the thing we can be able to tell. So guys, I'm while I'm drawing lines, I will tell the points. While I'm drawing the lines, I will tell the points. Then try to understand those points here. Okay. While I'm drawing, I'll tell the points. So try to get the points. What I'm trying to say. Bus topology, ring topology. I will draw and I will explain. I don't give lines. While I'm drawing only, I will tell. So please try to understand. Of course, in PPT, there is a bus topology, ring topology explanation is there. Okay. First, I will draw bus topology, ring topology, mesh topology as a one, remaining topology as a second part of drawing. If it is a paint brush, it is quite easy, but I have to draw here. Okay. Yes, I have a devices. I have a devices. I can use a little small size also. Okay, this is
It is a bus topology.
yes, very good. It is a bus stop also. There is a backbone wire. This backbone wire is usually a kind of coaxial wire. The devices in the network you are connecting to this backbone wire only. Okay, as you know, in a olden days we have a cable TV network. So the cable will draw from home to home, and they are connecting from that main cable to our in TV set. Okay, it's a similar kind of stuff only. So they use a coaxial cable to connect these things. Okay, so this is so I have a devices A, B, C, D. Every device is communicating through this backbone wire only. Okay, A want to communicate it to B, like this it will communicate. A want to communicate it to C. A want to communicate it to D. Means all communications go through this single backbone wire only. Okay, so this is called a bus topology. Every device is connected to a single backbone wire. But there is a problem. There is a problem. What is the problem? If this wire is broken, if the wire is broken, so further communication will be stopped. Further communication will be stopped. Means A cannot communicate it to C, or B cannot communicate it to C or D. The further communication will stop, and it is difficult to troubleshoot also. It's little difficult to troubleshoot because it's a mainly backbone wire. If it is damaged, communication problem. Okay, so and we should locate where exactly issue is there. Then only then only we can able to repair it. Okay, it is easy to configure, very cheaper solution it is, but problem is it depends upon a backbone wire. If some place any problem you got it, a backbone wire got cut, so further communication will be stopped. This is the bus topology. Next, bus topology. Here in this one, every device a device is connected to another device. For example, A is connected to B, B is connected to C, C is connected to D, D is connected to E is connected to A. Okay, E is connected to A. This is called a ring topology. Ring topology. What is a ring topology? Every device is connected to, sorry, not every device. A device is connected to other device. That device is connected to another device. Another device is connected to another device. Okay, so this is called a ring topology. Is it difficult to scalable? Of course, because we'll go to scalability later. Guys, A is connected to B, B is connected to C, C is connected to D. Like a device is connected to another device, other device is connected to another device. Finally, last device is connected to first device, and it will form a ring. What is the advantages? So it will communicate A to B, B to C, D to A, like this. Okay. If A want to communicate it to D, A send a packet to B, B send a packet to C, C send a packet to D. D want to send a packet D to E, E to A. Okay, it's always follow a clock direction, anti-clock or a clockwise or anti-clockwise direction it will follow. Okay, if in case,
Sir,
yeah,
sir,
tell, tell.
if the device A damages, then will it affect all the devices?
Yeah, that's what I'm trying to say. Okay, if this wire is broken, for example, this wire is broken between B and C. So A will communicate it to B, but A to C communication is stopped. See, this line is
Yes,
not.
sir.
But C can able to send message to A, but A cannot send
D.
to C. Okay,
But
this
sir,
is
in opposite direction, it cannot run like A to E, E to D, and D to C.
very
Whether
good.
A communicate to C.
Yes, yes. That's another solution is also there. It is this topology is works based on an algorithm. Okay, so they will create every time means they when they added a devices they will define you should communicate either in a clockwise direction or anti-clockwise direction. Means A will send a packet to B, B to C, okay, C to D, D to E, and A like this only. It's a one side of clock. Yes, very good. If in case A to C communication is stopping because of this line is broken.
Then
And
anti-clockwise start
then,
running.
yeah, very good. Very good. That is, they will put two paths. One path is for clockwise, another path is for a anti-clockwise direction. This is called a double ring topology. Double ring topology means what
Sir, then
happened?
sir, then it will start working from B to A to F, F to D to C,
Yes, one
like
path,
this.
one path is like this, another path is like this,
Okay, sir. Anti-clockwise, basically.
anti-clockwise. There are two paths are there now. So what
Yes.
if happen? What is thing is happen? If this wire is broken, communication is there. Either so A B C communication is stop. A B B to C communication is stop. But A E D C communication is there. Okay. So at least
Okay, sir.
one direction communication is there. Either this direction or that direction communication is there. Or a device is down. A device is down. So C won't communicate, but A B E D these devices will communicate. It will send a packet like this, and it will send a packet like this. Understand? So path is broken, but still there is a communication in the double ring topology. In single ring, it's become difficult. And one more point is there. So that is called a scalability point. What is scalability? If I add one more device, if I add one more device, what will happen? I have to create lines again. I have to change the path. I have to configure it again. You have to communicate like this. Okay, I have to configure it again. You have to communicate entire communication path. I have to define for every device. For every device. So it is very difficult to scaling. So what is scaling? Ability to increase. Ability to increase. Now you have 5 devices. Can you add 10 devices? Can you add 20 devices? That is ability to scalability. Here it is scalability is difficult because you have to go to each and every device and you have to configure. Yes, sir.
I have a question.
Hmm?
Sir, I have a question. May I
Yeah,
ask you?
tell.
Sir, ring topology is a unidirectional or not?
You ring topology, generally ring means it is a unidirectional only. Okay, but
So
if
it
one
can
direction is, yeah, tell me.
it can go system A to B, na, and
Yeah,
it can A.
it's got. Yeah, it's a unidirection, A to B, B to C, C to D, D to E. So only one direction flow, one system given. Like my destination is D. So I told to I'm sending to D. So but B takes and forward to C. C to D, finally it is reaches.
Sir, system A can share data to system E or not?
Yeah, it can share.
It can share. Okay.
Yeah. A to E communication is there. E to A direct. E to A direct. But A to E multiple steps.
Okay.
Okay. So, but unidirection means that is clockwise or anti-clockwise. But if you want A to A to E to A direct connection, means you need to go double ring topology. Means two directions. One is clockwise, another is anti-clockwise. So algorithm works like this, which is the nearest one. Clockwise direction is nearest, anti-clockwise is nearest. So based on that, packet will send. Okay, in the ring topology. And it is difficult to scale again. Why? Because of, again, you have to go to each and every system to configure what path it should be communicate and connectivity.
So,
Yeah, tell me.
so, does the number of devices affect the efficiency of the network?
Yes, of course,
It affects.
it affects
Okay.
efficiency. Definitely affects.
Okay.
Number of devices increases. What happen? I have a 10 devices. Think like this: A, B, C, D, E, F. Last device I want to communicate. Okay,
So,
more bandwidth.
if the number of devices increases, then the efficiency will decrease, right?
Don't we don't go to efficiency part, guys. Exactly. But I'm trying to say it is number of devices increases. Obviously, bandwidth demand is increases. Link will be more demand. That means obviously think like this. So I don't calculate any efficiency. I'm not talking about efficiency. Which
Okay,
matter
sir.
it is, I don't. Okay. Think like
Okay,
this.
sir.
Morning 5 o'clock. You want to watch a YouTube video, heavy HD mode. Very fast it will load.
Okay, sir.
6 o'clock, 7 o'clock, 8 o'clock. So load increases, right? Broadband utilization increases. So lot of devices are connected. So demand increases. Obviously, the performance reduces. That means morning 5 o'clock speed, how much speed it is, that much speed you don't feel after 9 o'clock, 10 o'clock. Night after 9, 10, you don't feel that much speed again. After 1 o'clock, 2 o'clock, you feel again speed. It's a general point. It's just automation, sometimes good, sometimes very bad. It is deciding what I have to draw also. Anyone guess what topology it is and what I'm missing here?
It
Mesh
is a
topology,
mesh.
sir.
Very good. It is a mesh topology. Okay,
Mesh topology, sir.
very good. So in mesh topology, every device is connected to all other devices. Means A is connected to B directly. A is connected to C directly. A is connected to D directly. A is connected to E directly. Let's see A, B. B is connected to A, E, D, and C. C is connected to A, B, D, E. Like this. Every, every device is connected to all other devices. Actually, we can draw one more topology here also. Okay, that's what it is. The mesh topology it is. Okay, bus topology, ring topology, mesh topology. Okay, three topologies. Mesh topology, every device is connected to all other devices. So somewhere we are missing, that is a C to D is not connected. That's in a drawing problem. Okay. D is connected to C also. Okay, so guys, it is a complex configuration. It is a complex configuration. It is complex. First point is it is a complex. Second one, difficult to troubleshoot. Difficult to troubleshoot, but highly redundant. Redundancy is there. What is redundancy? If one device is down, no problem. Other device will give you the service. Okay, that is called a redundancy. One device is down, no problem. Other device will give you the service. Now, if you see, for example, C to A communication is down. You know how people will draw generally. So you take this, 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 this. So when you see it is look like a drawing is like that only, guys. The original it is look like this. Mesh topology. So A, B, C, D, E. For example, B to C connection is down. No problem. Remaining devices are communicate each other. B2C direct communication is not there, but we can communicate with other devices. C can communicate with the other devices. B2C communication is down. That's it. Second one is if in case a device is down, if in case a particular device is down, only that device is down. Remaining devices will communicate each other. What he is doing? A lot of noise today is a full of headache class. Remaining devices will communicate each other. Okay. Of course, it is difficult to troubleshoot and it is complex. Redundancy is there and difficult to scalable. What is scalability? Ability to increase. Can I increase my infrastructure like this? Number of devices. Then how many connections I have to make it like this. And where we use this mesh topology. And we are not using a ring topology and bus topology, but we are using a mesh topology not in regular LAN networks, where we use in server rooms, storage connectivity like a SAN storages areas, okay, local means server rooms, core networking areas. So they will connect one server to another server to another server, or one server to every server in mesh topology. Actually, they use hybrid type, but mesh is also works like that. Okay, core servers, SAN storages, core networking areas. So we will use this type of mesh topology because of it's not like one device is down, no problem, all other devices will communicate. One line is broken, no problem, remaining communications are going good. So that it is not a collateral damage, but it is difficult to scalable, difficult to troubleshoot, complex to configure, and it is redundant. That's it. So these are the first three topologies: mesh topology, ring topology, and bus topology. Guys, understand the first three topologies?
Yes, sir.
Yes, sir.
Alain. Okay. You have to use a centralized device called a hub or a switch. You have to use a centralized device called a hub or a switch. It is making me more crazy. Irritate. Okay. Yeah, not required to connect there. See, the devices are connecting to a centralized device. The devices are connecting to a centralized device. Okay, all devices are connected to a centralized device. Okay, so all are communicating through the centralized device only, not direct communication. In ring bus topology, all communicating through backbone wire. Ring topology, all are communicating either directly or through one device to another device. Mesh topology, direct communication. Mesh topology, one device to another device, direct communication. But in a star topology, this is called a star topology. How we are communicating? So you have to send a packet to this hub or research, and then you have to send a packet like this. All we should communicate it through this one only. Okay, everybody should communicate it through this. Okay, like this. All communication through centralized device only. So what is this topology? We call it as R topology. Guys, it is very easy to configure, easy to troubleshoot, but not redundant. Why? Because of it depends upon this switch. That depends upon the switch. All we are communicating through switch, and we are additional switch, again additional cost, right? You are not only using a wires kind of stuff, devices and wires. Also, you are additionally we are using a device, means additional device when required. Okay, think like this, guys. All are communicating, all devices communicating through this hub or a switch. Either you can use hub or a switch. Next, just in case the cable is down, just in case a cable is down, only one connection. For example, for a CPC. For example, for CPC. So what happened? CPC won't communicate. The remaining will communicate each other. For example, EPC is down. PC is not working. Only that PC won't communicate. Remaining devices will communicate. If in case this switch is down or hub is down, all communication is stopped. Of course, still there is a positive thing. It is very easy to troubleshoot. Why? Because we know where issues occur through the your hub LED or switch or hub LEDs status connectivity, so we can understand where exactly issues occur. Okay, so this is star topology, and it is very easy to scalable. Means you can add additional device if you have a port available in the switch. Okay, not only that one, guys, you have a another topology. For example, I have multiple devices are there. Okay, so then I created another topology. But all devices, for example, I have 100 computers are there. 100 computers need to connect. 100 computers need to connect. Okay, so this is one topology. This is another topology. Both are in a same place, not different place. Both are in a same place. So we can connect directly from this to this. Become earlier it is different segment A, B, C, D, E, F, G, H. Just by habit 12. Okay. Now these devices can communicate each other. It's called as scalability. Adding, connecting this one switch to another switch, so then it becomes single segment. Means there is a two networks earlier. Now it is single network. Now it is single network. Okay, single segment. Two segments become single segment. Or two networks become single network. Okay, this is a scalability. In a star topology, you can add a multiple number of users, sorry, multiple number of computers by scaling your topology size. That is called a extended star. It's called a extended star concept. This is extended star. I am extending my star topology. It is scalable. Scalability. guys, again, star topology. Every device is connected to centralized device, either it is hub or a switch. All devices are communicating through centralized device only, that is hub or a switch. If a connectivity is missing, like a connection to device is missing or down, only that device won't communicate. Only that devices won't communicate. All other devices will communicate. Okay, point number one. If device is down, one device is down, no problem, all other devices communicate. But centralized device is down, means hub or a switch is down, total communication is stopped. But star topology, easy to create, easy to configure, easy to troubleshoot.
And
Easy
sir,
to
what about
troubleshoot.
redundancy?
Tell me.
What about redundancy in this star
No
topology?
redundancy. Very good, very good. No redundancy. Okay. No specific redundancy. If centralized device is down, total collapse. Okay. One way or other way is not a chance. But it is good in scalability. We are all using on our regular networks star topology, not mesh. We are using star topology in our regular network. Okay, so this is about your star topology. Very good. Guys, just for a card only, we are telling point to point topology. What is this point to point topology? You connect a device to another device directly. For example, you can see A is connected to a switch, point to point. Okay, in a mesh topology, A is connected to B, B is connected to C. That is also point to point. In a ring topology, A connected to B, B connected to C. That is also point to point topology. So now separate point to point topologies here. But in WAN connectivity, so we use so everything is a point to point, means you connect one device to another device, point to point. Okay, direct straight one connectivity to another connectivity. Okay, so this is point to point. Everything is point to point, but in some cases, like a router to router, that kind of point to point is there. And there is a point to multi-point kind of stuff is also there. Okay, so point to multi-point. What is point to multi-point, guys? For example, in a WAN technologies, this is the point to point. This part is PPP connection. It's like a WAN connectivity type. Okay. So for example, I have an office, main office is there. It is connected to, okay, another office, branch office, okay, corporate office. So multiple places I have a branches are there. Okay, multiple places I have a offices are there. So what I'm doing is I'm connecting one point to multiple places. So that is called a point multi-point. Just for logical purpose we are doing, otherwise you can do multiple interface. Just for a figure purpose only, guys. Not really it is like that. Not really like that. Okay. So here it is. I have a multiple branches. So multiple connectivity from main office to multiple branch offices if I'm connecting. So point to multi-point connectivity. I'm connecting one place to another place, one to another one. This is direct connectivity. It is point to point connectivity. Okay. So important already at all. There is a one more is there, that is called a tree topology.
So what about hybrid topology?
Hybrid is it's a combination of two or more topologies together. It is a hybrid topology. Combination of two or more topologies together, hybrid topology. For example, mesh and star topology, hybrid. And every topology almost all hybrid only because of it's a point to point plus star, point to point mesh, point to point ring. Okay, these are the hybrid topology. Now I show you tree topology. Tree topology is a pure form of hybrid topology. Okay, that's why I like that one. Even I don't go through that part. Means usually don't suggest that one, but recently I found this type part. I like it. This is a tree topology. Can expand up to somewhat. Okay, this is a tree topology. I can't draw, so that's why I given. See, it is the center one is a backbone wire to something. Your devices are connected to backbone wire means bus topology, but it is not bus topology. Devices are not connected. What it is connected to some other topologies. There is a switch and there is a devices means computers, servers kind of stuff, and there is a server is also connected directly, and there is some extended hub is connected to the backbone wire. So this is like a tree topology. Tree topology is a pure form of hybrid. See, bus topology is there, star topology is there, direct point-to-point connectivity is also there. So this is a tree topology. Now you are getting reliance, right? Reliance is like it's a kind of tree topology only. They are drawing some wire from okay guys, understand topologies, network, networking, internetworking, okay, physical network, logical network, physical topologies. Okay, so these are the few things, and of course LAN man can kind of stuff is there, but better to take a small break. Okay, 15 minutes is enough. So when we'll be back? For 45 or 50. Okay.
Okay, sir.
So maximum be there at 4:45. 5 minutes. Okay, no problem. For today.
Okay.